This is another example on how to do detailed analysis and a quick analysis of an algorithm. The algorithm in this example is simply a toy or dummy algorithm. Its purpose is just to demonstrate on how to analyze an algorithm and how to find its time complexity, that is also called efficiency. We don't even know what problem it is solving. As you can see, it does not have name nor input parameters. By looking at the code, in line 1 it has an assignment statement. Line 2 also it has an assignment statement. Line 3 it has a for loop that goes from 2 to n. And in line 4 it has an arithmetic statement that is repeated in every iteration of the for loop. By looking at the line inside the for loop, it consists of 3 operations: the multiplication, the addition, and the assignment statement. Notice that as the value of n is increased, then the number of iterations of the for loop will increase, as well as the running time of the algorithm will increase. Therefore, we will assume that n is the problem input size that we will use to find the time complexity of the algorithm. Now, to do detailed analysis, we need to count how many times each operation is executed. And to do that, we will go over the algorithm line by line. So let us start with line 1. Line 1, we have an assignment statement. And this assignment statement is repeated only once, so the frequency is 1. Line 2, we also have an assignment statement. Also, it is executed once. Now for the for loop, it has 3 operations. First is initializing the value of I by 2. So it is an assignment statement. This is line 3. So we have an assignment statement that is repeated only once. We have testing, which is comparing the value of I against n. If it is true, we enter the for loop. And if it is false, we exit the loop. Notice that the number of iterations of the for loop from 2 to n is n-1. So in every iteration, we are comparing I with n-1 times, plus the last comparison that will make us exit the loop. Therefore, the number of times will be equal to n. Finally, the increment of the value of I, and it is repeated n-1 times because the for loop will be iterated n-1 times. Line 4, this statement is executed n-1 times. It has assignment that is repeated n-1 times. It has addition that is also repeated n-1 times. And finally, it has multiplication that is also executed n-1 times. Now, to find the time efficiency or time complexity, then we need to add all of these frequencies. So we write Tn is equal to 1 plus 1 plus 1 plus n plus 4 times n-1. And this will be equal to 5n minus 1, which belongs to big theta of n. Now for the quick analysis. To do quick analysis, we need to find the basic operation and how many times it is executed in the algorithm. And to do this, first we need to find the line number that is mostly executed by the algorithm. And this line is line 4. Why? Because it is inside the for loop and it is repeated in every iteration of this for loop. But this line consists of 3 operations: multiplication, addition, and assignment. So which operation is the most time-consuming operation? We know that the CPU or hardware, when it multiplies 2 numbers, it takes a lot of execution cycles because it follows a certain algorithm. So practically, multiplication takes more execution cycle than addition, takes more execution cycle than the assignment. So the most time-consuming operation is the multiplication. But as a special case for multiplying by a power of 2, the hardware in fact does not multiply when one of the operands of the multiplication is a power of 2. In fact, the operation tends to be shift left by 1 bit when we multiply by 2. Let me show you by an example. Suppose we want to multiply 6 by 2. 6 in binary is 110 and 2 in binary is 10. So when we multiply 6 by 2 in decimal, it is a 12. And when we multiply 110 by 10 in binary, it is 1100. Now see the value of 6. When you shift one bit to the left, then it will be 110 and we add 0 to the rightmost digit. And as you can see, it is equal to the answer, which is equal to 1100. So when we multiply by 2, the hardware in fact does not multiply by 2. It shifts one bit to the left. So therefore, it takes a few execution cycles compared to addition. In this case, we will not consider multiplication as the basic operation, because in fact this is not multiplication, it is shift left. So therefore, in our example, the basic operation will be at line 4 and the operation is addition. Now how many times this addition is executed in the algorithm? This addition is in a statement inside the for loop, and this for loop is repeated in -1 times. So the time efficiency will be equal to n-1, which belongs to big theta of n. As you can see, when you do detailed analysis or a quick analysis, you get the same time complexity that is equal to big theta of n. Therefore, it is more practical to consider the quick analysis instead of the detailed analysis. Why? Because by knowing in advance that it is enough to consider only the basic operation to get the time complexity, it is unnecessary and waste of time to consider the other operations that we know their frequencies will never change the final result of the time complexity.